Hi everybody, this is Tom Cherry Holmes with Errata Online, and I've recently completed an alpha version of a port of Plato Term, the Errata Online Plato Terminal, for accessing services like Errata Online and cyberserve.org, aka cyber1.org, with Plan 9. I won't go too much into the details of what Plan 9 actually is. Suffice it to say, it's a very unique operating system. It was designed for distributed computing research by Bell Laboratories in the late 1980s and was used by Bell Labs community for almost 2 decades after that point. It's very unique in that basically it was created by some of the founders of the Unix operating system, utilizing their experiences developing and using Unix to make what they considered to be Unix's next possible evolution. It didn't take off en masse, but that's okay. It was released under an open source under an open source license, so you can test this and try this if you want to. And to that end, I wanted to take and port Plato Term to it, so that Plan 9 users can have another thing that they can do with their systems. And I would like to say that the port to Plan 9 has proven to be one of the most enjoyable ports that I've done of Plato Term, and I've done over 24 of them at this point. I'm going to go into a little bit of the code at the end of the video to show some of the features that I thought were kind of interesting. But for now, let's go ahead and just log into the system here. I'm going to use a particular piece of software called DrawTerm, and DrawTerm is essentially a graphical terminal that can connect to a Plan 9 CPU server. I have a physical Plan 9 system on the network here that is exposing a CPU server that you can connect to, so you can use the machine's CPU and other resources. It also exposes a file server and an authorization server for file storage and authorization, respectively. But for right now, all I have to do is specify the host name that I want to connect to. And it's called Retro. The auth server is also at Retro, and I'm going to log in as the user Glenda. A few moments it will take and ask me for a password. I go ahead and enter it. And despite the error message that you see right here, we're actually logged onto the CPU server. Everything's good. You can see I have a mouse cursor here ready to go. And we'll go ahead at this point and start the windowing system. The windowing system starts up and everything is blank, and not much seems to happen. If you take and press the left mouse button, there's nothing to select, so you don't really see much of anything. But when you press the right mouse button, you get a menu, and this is probably one of the only actual what you would call widgets in the Plan 9 windowing system. Is essentially a menu widget. We'll go ahead and select New to create a new window. You'll see my cursor change to a cross. Now I'm going to make a small note here that because of the way OBS is capturing this particular window, the mouse cursor and the display are not lined up together. I apologize for this in advance. But for now, we'll go ahead and create a new window, using the right mouse button to take and drag the window down into our desired size. And once that's done, we can see that we are essentially running a shell window here, and Unix users would recognize this as basically an Xterm, more or less. Plan 9 is rather unique in that Plan 9 and its windowing system Rio act as resource multiplexers. That is, each individual window that is running here is getting its own input, output, mouse devices, event devices exposed to them as if they were the only programs running on the system. And this division and multiplexing of input and output and subsequent labor is so clean, it is actually possible to take and run things like the windowing system inside itself, indefinitely if you wish. I'm able to take and it's keeping track of the windows that are out here on my main system, as well as the nested windows inside of here, keeping all of this, nicely kept track of, everything cleanly divided. We don't really need this, so we'll go ahead and delete this window here, again using the window menu, delete, and we'll delete these. And I will take and actually move this guy over and resize him just a little bit so that we can get some space. And we're going to go ahead and grab a copy of PlatoTerm for Plan 9. Now, I've already installed a Git client called Git9. It's an excellent Git client. We'll see where we are right now. We're in my home directory. My home directory has a source directory, so I'll go to it. And I'll just go ahead and grab it again. I'll remember. I think I already did, but... Okay, so at least that's not there anymore. Okay, sorry about that. I didn't finish cleaning up there. I always do various dress rehearsals. So we'll go ahead and clone this from GitHub. A few moments, it'll be here. And then, boom, there it is. Now all I have to do to build it and compile it is to use the make utility mk to compile it and install it. It did both. Great. Excellent. And at this point, I can then take and run PlatoTerm. If I run PlatoTerm with no parameters, it gives me a usage statement indicating that there is at least one required parameter for hostname. The port parameter is not required, but you can use it to overwrite the port number if you need to. By default, since this uses the ASCII Plato protocol, and we've agreed upon port 8005 being the ASCII Plato protocol port, it will use 8005 by default. We'll go ahead and log into errata.online, but you'll see in the README file that there are other hosts that you can connect to as well. Now, the interesting thing about Plan 9 in and of itself is that the applications that run in Plan 9 take over the window. We'll go ahead and log in. Here we go. Bam, all good. Now, of course, that's running here, and I can, of course, take and do another one here. We can log into cyber1.org. Since this is July 4th, they did a custom login screen here, which is very nice. Now you'll notice here that you'll see references to certain things like special keys, next, shift back, etc. And to press those, you will actually use the menu. If you press the right mouse button key, you'll see a number of keys that you can press here, and selecting one of them will press that key. The middle mouse button provides the shift equivalents for those keys. We need to press the shift stop key, so boom, shift stop, there it is. We find ourselves logged in there, and we have access to CyberOne. Of course, we can asteroids, press the data key, and there's asteroids running right there. Looking great. Now, of course, the touchscreen for the Plato terminals is also emulated. It uses the mouse to map, so you can select using the mouse. We'll take and select public notes. See that public notes comes up just fine. Boom, there we go. We're reading notes. We're doing just great. Okay, we're done. I can either hit back and look at other notes back, or I can do shift back, get out of here, shift back again, come back to the menu. Of course, I can hit shift stop at any time to basically break out of anything that I might be in. So we can go look at some of the other bits and pieces. Let's say games, or no problem. Lots of great games on both Errata Online and cyber1.org. Things like Avatar, for example. Avatar is a wonderful MMORPG. Yes, it's multiplayer. And it's very large, multiple levels, etc. Just really, really neat to deal with. There's Avatar. Of course, we're done. Okay, take and break out of it. Sure, no problem. Come on. Uh-oh. Yeah, let's get out of here before I die. Oop, and I accidentally hit it again. So now we're back to login screen. No big deal. Since I'm pretty much done with this right here, I will go ahead and basically just drop this. We'll just drop this window here. Done. And I will say that running this on the local machine is even better. I'm running all this just through a draw term, so I could develop it and so I could use it. So you can see it's a fully functional Plato terminal. There are a couple of things that need to be implemented, such as paint, because you'll notice everything is hollow. And I just need a good flood fill algorithm for that. So there we go. Once we're done, we can of course either hit quit or we can hang up, at which point it will drop us back to shell prompt. Now for this next bit, I'm actually going to take and resize this window ever so slightly here. And we're going to look at the code in Acme. See where I am. We're inside the Plato Term Plan 9 directory. And we'll use the Acme text editor / Swiss Army knife. Take a look at it. We have a directory view on the right-hand column here. And selecting a file using the right mouse button will bring it up in a new pane that I can take and drag over here. Start by looking at platoterm.c, which is the entry point. You'll see it's over here. We'll take and pull it over. And a couple things to note. You'll see right here, for example, the text for the menu. And you'll notice because Unicode was invented in Plan 9, Plan 9 actually supports Unicode characters all the way down the operating system stack. It does it natively, and you can use your compose key to take and compose these characters. It has no problem dealing with them, and in fact, the compiler you can even use these variables such as delta or sigma for things like variable names and the like. It effortlessly handles those, which I thought was extremely impressive. The code itself is just overall extremely simple. This is the entirety of the main program. You have a macro for creating a switch statement for argument processing, including grabbing values for options with error checking and everything handled inside the macros themselves, making it nice and simple to deal with. And we'll notice that we then go into, once we have everything set up, we set up the drawing canvas, set up the terminal state machines, everything else, and immediately go into IO init. Apologies for that. We go into IO init. And IO init actually takes and creates the connection. And what you're about to see here, if you've done any sort of Unix socket programming, this will surprise you. We'll go ahead and delete this here because we don't need it anymore. Middle mouse button, pull away, and we see IO init. And what you're seeing right here is everything that you need to open a network connection to a remote service. For Unix, this would involve creating a socket, setting the socket options such as blocking versus non-blocking sockets. You would have to handle name resolution yourself, taking the results from the name resolution, putting them into address fields, filling into the address fields for the sockets, calling connect yourself. All of that gets collapsed entirely into a single statement. And netmkadder isn't what you think it might actually be. Netmkadder just simply takes these three values right here and constructs a device string that it sends directly to the clone control socket to take and create a new TCP socket, or create a new network socket. That's it. And that's everything you need to handle, all of the setup for a network resource. And what you get back is not a socket. It's a file descriptor. It is a pure file descriptor in every sense of the word. The operating system sees it the same way as it would see a local file or resource. No distinction. And thus, because of that, you can use things like read and write to directly deal with that socket. But it gets even better. If we come back to the main program itself, we'll see that one of the things that actually happens, go ahead and delete this right here. I'll just move this up a little bit. One of the things that happens once we get back here, we have our network socket, file descriptor. I keep calling it sockets out of habit, but it's not. It's a file descriptor. And we have this right here called eStart. And what eStart does here is it hooks that file descriptor into the event subsystem so that whenever anything appears on that file descriptor, it will fire this event, thus making event-driven handling of the receive socket, the receive file descriptor easy. Because all that will happen, boom, the event fires down here. It will take care of reading that file descriptor into the event payload, telling you how big it is, and you can pass that directly into your into whatever you need to do it with. And you'll see right here that IO main is nothing more than a call to the terminal state machine to process the data. Once that's done, we subsequently go ahead and update the view, which basically just takes the view that we've constructed and blitz it to the screen. That's it. And the screen functions are similarly easy enough to deal with. Really easy. It's amazing, really. Delete. We resize the window by basically sending commands to the window control, to our copy of the window control socket. Simple. We get events for handling things like window resizing, so that we can take and set up our views to match. Updating views, sending draw calls to update the views. Things like using our copy of dev audio to take and write our console beeps, and so on and so on. These are all standard calls that are part of Plan 9 itself. Just part of the operating system, part and parcel. And so on. So with that, seriously, that was a little blip of mine there. So with that, I think I'll end the video here. But I wanted to show you guys just a bit of what I thought was rather interesting in porting Platoterm to Plan 9, and why I think Plan 9 is worth a look at if you're interested in seeing other ideas on other operating systems and getting good ideas from these operating systems. So with that, I hope you guys have enjoyed this, and until next time, have fun.